Hello everyone, welcome to my channel. In this video, we will learn about the introduction to dynamic programming in the design and analysis of algorithms. So in this lecture, we are going to learn about what is meant by dynamic programming and how it differs from divide and conquer and greedy method, and what are the applications of the dynamic programming. Dynamic programming is a stage-wise search method suitable for optimization problems whose solutions may be viewed as a result of sequence of decisions. So here, in the case of the greedy method, so we are considering some feasible conditions. So we are considering a subset of inputs and which are feasible, that means which satisfy certain condition, and then from that feasible solutions we are considering the optimal solution, right, in the case of the greedy method. Okay, but in the case of dynamic programming, we are searching for the optimal solution in the stage wise. That means, so we are not directly considering the optimal solution based on the given set of feasible conditions, but so we are selecting the optimal solution stage wise, that is level by level we are selecting the optimal solution. And dynamic programming is more efficient than greedy method. So the technique decomposes original problems into small subproblems which can be handled more efficiently from computational point of view. So in this dynamic programming, we are going to divide the given problem into small subproblems, and the small subproblems can be handled very easily. But it is not similar to divide and conquer method. In the divide and conquer method, so we are dividing the problems and all the problems are independent here, right? So you have to remember that point. So the problem that we have divided in the divide and conquer method are independent, the subproblems are independent. But in the case of the dynamic programming method, the subproblems are overlapping problems. So that means there is some relation between these subproblems. So it takes advantage of duplication and arrange to solve each subproblem only once, saving the solution for later use. So it takes the advantage of the duplication and arrange to solve each subproblem only once. So while solving a problem, we may face some of the duplication. That means we will be wasting the time solving the same problem again and again. Okay, so this dynamic programming will avoid the duplication of solving the same problem again. Okay, so if it founds the same problem and solution again here, so it will skip that part in the dynamic programming method. So now let us see what are the differences between the divide and conquer, greedy and dynamic programming methods. So in the case of the divide and conquer method, if you consider the optimality, okay, so it may or may not find optimal solutions. In the divide and conquer method, it may or may not find the optimality, the solution may or may not be optimal. And the greedy method also, the solution may or may not be optimal. But in the dynamic programming method, it will guarantee the optimal solution. Why? Because we are searching the solution each level by level. So we are searching each possibility of finding the optimal solution. Subproblems. So the subproblems are independent in the case of the divide and conquer method, whereas in the case of greedy method, it is feasible set to find the optimal solutions, right? So in the greedy method, we are taking the subset of inputs from the given n number of inputs. We are considering some subset of the inputs, and so how we are finding the subset of inputs means based on some constraint or condition. So we are forming a feasible set, and from that feasible set we are finding the optimal solution. But in the case of dynamic programming, the subproblems that we are dividing a problem into number of subproblems, right, that subproblems will overlap. So that means there will be some relation between the subproblems. Next one is implementation. It is simpler. Divide and conquer method is simpler and greedy method is also simpler, but dynamic programming is more complex than these two methods. And the space complexity is lower in both the divide and conquer and greedy method, whereas in dynamic programming method it is very high. Why? Because we are storing the tabular form of data about the problem in the memory. That's why the space complexity is high in the dynamic programming method. Unlike divide and conquer method, which solves the subproblems top down, a dynamic program is bottom up approach. So in the divide and conquer method, we are dividing some problems into subproblems, right? Each problem we are dividing it into subproblems. But in the case of dynamic programming method, this will be reverse. Okay, so divide and conquer is a top to down approach. That means we are taking a problem, dividing it into subproblems, and then after finding the solution, so we will find the common solution, combined solution. But in the case of dynamic programming, we are considering the bottom up approach. That means first we are solving the subproblems here, and then we will go to the next level, and then to the next level. So finally we will find the solution. Right. So this is a bottom up approach. So how do we solve the subproblems of dynamic programming? So start with the smallest subproblems, combining the solutions, obtain the solutions to subproblems of increasing size until arrive at the solution of the original problem. So we are starting from the bottom, that is from the subproblems, and then so we are combining the subproblems to the we are combining the solutions, obtain the solutions to subproblems in increasing size until we arrive at the main solution here. So dynamic programming is based on the principle of the optimality. So it is based on the principle of optimality, and there are multiple number of applications of dynamic programming. So they are multi-stage graph, optimal binary search tree, reliability design, traveling salesperson problem, and 0-1 knapsack problem. So these are the different applications where we can apply the dynamic programming method. So the next video we will see how can we apply the dynamic programming on multi-stage graph. Thanks for watching my video.